Hi everybody, welcome back. This video is going to show you how to do something called u-substitution with indefinite integrals. What that's going to allow us to do is it's going to allow us to take antiderivatives and indefinite integrals of more complicated scenarios. So they'll kind of look like this, except you've already done this integral before because we can easily rewrite this integral by multiplying this binomial out and then distributing the x. So here's what that would look like. You could square this binomial, distribute the x to get x to the fifth minus 2x cubed minus x dx, and then integrate. So add 1 to the exponent, you get 6, divide by the new exponent, 1/6. So if I do all that, this is what you guys did last time. Now that was all fine, and it wasn't too bad to square this binomial first and distribute. However, if instead of this exponent being a 2, if it's a 5, that's a whole different story because nobody really wants to multiply x squared minus, well, I don't want to say nobody. Not very many people will probably want to multiply x squared minus 1 out 5 times. You might enjoy it. I don't want to speak on your behalf, but it is a lot of algebra to have to multiply this out 5 times. So instead, we can use something called u-substitution. U-substitution, what it's going to do is it's going to allow us to rewrite this expression into a simpler one that allows us to integrate. So we're going to take this expression and we're going to transform it. So the first thing you'll need to do is you'll need to let u equal something. Now, usually what you want u to be is whatever's inside parentheses. If you don't have parentheses, it might be a number under a square root. It might be a number in a denominator. And I say number, but I mean expression. Or it might be an expression inside of a trig function. So these are some places where you can look for whatever you want u to be. In this problem, I noticed that I have an expression in parentheses. So I'm going to come over here and I'm going to say that I want u to equal what's inside the parentheses. So this part's going to be u. So I'm going to let u equal x squared minus 1. Step 2 is to find du dx, which is du dx is the derivative of u. So the derivative of x squared minus 1 equals 2x, derivative of x squared is 2x, and derivative of negative 1 is 0. So here's the derivative. Now step 3 says to take this u and du dx and rewrite everything into terms of u's and du's. But to do that, see how there's a dx here? I need to solve my derivative for dx. So I'm going to multiply both sides by dx to get du equals 2x dx. And then if I divide both sides by 2x, then I'll get du over 2x equals dx. So that is going to allow me to work on step 3. So I'm going to draw a little line because I need all this space here. So now I'm going to rewrite everything in terms of u's and du's where I can. So integral. Now this x I can't rewrite because I don't have anything that x isn't equal to any u. So I'm going to bring it down. But I did say what's up was in the parentheses, x squared minus 1 is equal to u. So I'm going to replace this with u. That fifth power is still going to stay there. And then dx I can replace because I know that dx is the same as du over 2x. So then I have everything written in terms of u's and du's almost. Now I can't integrate, can't go on step 4 until all of my x's are gone. So I need only u's and du's. But if you notice, I have an x here and a 2x in the denominator. This would be like having all this over 1. So if I were to multiply it all out, this would be the integral of x u to the 5th du over 2x. and the x's cancel. And this over 2 is the same as having 1/2. So I really have the integral of 1/2 u to the 5th du. Now I can say that I've rewritten everything in terms of u's and du's because there are only u's and du's left in the problem. There are no other variables. Now I can do step 4. I can integrate. So I'll add 1 to the exponent to get u to the 6th. Divide by my new exponent. So 1/2 divided by 6 is 1/12. And then plus my constant. So I've done that. Then all that's left for me to do is to substitute everything back in for u. So I'm not done until, see how my integral was in terms of x's? My answer needs to be in terms of x's. So I'm going to replace this u with the u that I have up here, x squared minus 1. So zoom out so you can see the whole picture. So I have my integral is 1/12 times, instead of u, I'm going to use x squared minus 1 to the 6th power plus a constant. And this is the indefinite integral of the original problem. So let's do a couple more of these. Now you'll probably want to pause and make sure you get all these steps down because they're going to be the same every time. It's just sometimes whatever you let u be will be different. So let's try a couple of these. And again, here it is one more time in case you want a screenshot. All right, so here we go. We've got the integral of 3x minus 2 to the 4th. Now I probably do not want to multiply out 3x minus 2 4 times. So instead I'm going to use u-substitution. I notice that there are parentheses here, so I'm going to come over to the side and I'm going to let u equal 3x minus 2. So now I can find du dx, which is the derivative of 3x minus 2, that's 3. And then if I solve for dx, multiply both sides by dx, I get du equals 3 dx. Divide both sides by 3, d over 3 equals dx. So I'm going to replace the dx and I'm going to replace this when I rewrite. So now with u substitution, I now have the integral, instead of the 3x minus 2, u to the 4th, and instead of dx, I now have du over 3. Now du over 3, that's the same as 1/3. So to make it easier on myself, I'm going to bring that 1/3 to the front. That. So now let's see how much simpler it is. I can apply that power rule. Add 1 to the exponent, I get u to the 5th. 1/3 divided by 5 is 1/15. U to the 5th plus c. And then I'll substitute the 3x minus 2 back in for u. So the integral is 1 over 15 times 3x minus 2 to the 5th plus my constant. Now this time I have a radical. The radical acts like parentheses. So remember before when I said u is usually going to be something in parentheses or under a radical or in the trig function or the denominator. That's what I'm talking about. So this time I'm going to let u be the 5x plus 4. Which means my du dx are the derivative. Make sure you write du dx. Don't write u prime because we have to replace dx. So I need something to solve for. Equals 5. Multiply both sides by dx. I get du equals 5 dx. So then divide by 5. Du over 5 is dx. So these are the things that are going to go into the problem. So I'll substitute 5x plus 4, and I'll substitute in for the dx. So now this is equivalent to the square root of u du over 5. Now the square root, I can't apply that reverse power rule yet, so I'm going to rewrite the square root as u to the 1/2. And this over 5 is the same as 1/5, so I'll move the 1/5 to the front. So 1/5 u to the 1/2 du. Now we're starting to get really good at fractions, so I'm going to add 1 to 1/2 and get 3/2. Divide 1/5 by 3/2. And I get 2/15 u to the 3/2 plus a constant. Substitute back in for u. So 2 over 15 times 5x plus 4 to the 3/2 plus a constant. There's the integral. Sometimes they look really scary like this. But just calm down, look and see, are there any parentheses? Yes, there are parentheses here. So let's see what happens when we let u be all of that. So let's let u equals 6x squared minus 7. So then that means my du dx would be the derivative. Derivative of 6x squared is 12x. And if I solve this for dx, I'll have du equals 12x dx. So then dx, if I divide both sides by 12x, I'll get du over 12x. So I'm going to use this. I'm going to use this. Hopefully when I substitute everything in, I don't have any more x's left. So this will be the integral of, let's see, 4x, can't substitute in for that yet, over 5. Now we said 6x squared minus 7 would be the u, so 5u to the 2/3. And instead of dx, I have du over 12x. And look what happens. These x's can divide out, so those are gone. And then 4/5 and that 12, I can combine those because it's like 4/5 times 1/12. So if I combine that together, I have 1/15 and then 1 over u to the 2/3 du. Can't apply that power rule yet because it's using the denominator. So to move it to the numerator, I can write it with a negative exponent. So I can rewrite this as the integral of 1/15 u to the negative 2/3 du. And now it's in that nice form, the form that we love. So I'll put a heart here. We love this form because it means we can apply that reverse power rule. So I'm going to add 1 to the exponent. Negative 2/3 plus 1 is 2/3. Let me just double check. I can't calculate right now. 1/3. It's 1/3. Negative 2/3 plus 1 is 1/3. I can add today. And then so I add that, and then I'm going to divide 1/15 by the new exponent. So 1/15 divided by 1/3 is 1/5. So 1/5 u to the 1/3 plus my constant. Substitute in what I had for u back in. 1/5 times 6x squared minus 7 to the 1/3 plus a constant. Let's do one more like that where it is kind of in the radical, because this time I have a cubed root instead of a square root. Did I have a? I should have had a square root last time. Yeah, to the 2/3. Okay. So I have a radical here. I look at this. Yes, there's no parentheses, but there's a fraction, but there's no x in there. So I'm going to look and see what does it inside a grouping symbol. Is there an expression that looks kind of complicated? Yeah, right here, that 5x squared. So I'm going to let u equal the 5x squared plus 1. So then du dx would be 10x. And then if I solve that for dx, I'll get, let's see, du is 10x dx. Divide both sides by 10x. So dx would be du divided by 10x. So let's substitute. I'll substitute in for there. I'm going to substitute in here. So this is equal to the integral of 5x times the cubed root of u over 3 times, let's see, we said dx was du over 10x. And I need to be careful here because that 3 is not 5x cubed. That is a cubed root. So I want to make sure that 3 is really close there. Now take a look at this. This x over the x, I can divide out those x's. And also 5 divided by 10 is 1/2. So I can go ahead and reduce that to 1/2. So now I have the expression, the integral of, let's see, the cubed root of u over the 3 times the 2 is 6. du's on the top or outside right here. And then I want to make sure I write this so that I can use the power rule. So I'll write it as u to the 1/3 because that's the same as the cubed root, u to the 1/3. And then over 6 is the same as 1/6 du. All right, now it's time to apply that power rule. Add 1 to the exponent, we get u to the 4/3. 1/6 divided by 4/3 is 1/8. So 1/8 u to the 4/3 plus a constant. Substitute 5x squared plus 1 back in for u. To the 4/3 plus a constant. There we go. Now earlier I mentioned trig functions. Yes, we're going to be working backwards with trig functions. So on the left side of your screen, you'll see all the differentiation formulas. So all those derivatives you had to remember earlier in the year, like the derivative of sine is cosine, derivative of cosine, negative sine, derivative tangent is secant squared, and so on. Well, the integration formula, if you go backwards, it's just those formulas backwards. So the antiderivative of cosine is sine. The antiderivative of negative sine is cosine. The antiderivative of sine, negative cosine. So it's all those backwards. So now we're going to do some u substitution with trig functions. So right here I have 3 sine of 1 minus 3x dx. Now remember earlier, way back, I said let u equal parentheses we've done. Square root we've done. Denominator comes up sometimes. Trig functions, whatever you're taking the trig function of, that's what you want to let u be. So if I have the trig function of something besides x, other than x, I need to use u substitution. So here I'm going to say that u is this 1 minus 3x right here. So I'm going to say that u is going to be 1 minus 3x, which means du dx, derivative of that is negative 3. If I solve that for dx, then I will get that dx equals du over negative 3. So I'll replace those two, which means that now I have the integral of 3 sine, not 1 minus 3x, it's 3 sine of u times du over negative 3. Now these 3's, 3 divided by negative 3 is negative 1. So now I have the integral of negative sine of u du. So what is the antiderivative of negative sine? Let's see. Well, derivative of sine is negative cosine. Antiderivative of negative sine would be positive cosine. So I'll say this is, let's see, cosine of u plus the constant Substitute in back in for u. So this is equal to cosine 1 minus 3x plus my constant. So as you're working on these, make sure you go through, anytime you see something written like this, cosine of 4x, that 4x should be in the parentheses, so you would let u be the 4x. In another example, you'll see several where it says 5x minus 1. You would let the u be 5x minus 1. You would let the u be 6x. And then you would just go from there. Now, if you get to, here's an interesting example. If you get to a point where you have like u to be x to the 4th, well, you'll see what happens when you get there. You'll see what happens. It'll come. But one thing I do want to emphasize is that you guys bring these formulas that you have memorized, bring those back to the front of your brain. So you want to make sure you have them because they do just pop up over and over. But that should be it for today.